Hello, my name is Mark Elliott, and I am the Chief Operating Officer of Europa Science, who is the publisher of Imaging and Machine Vision Europe. Welcome to everybody watching this live, and obviously to those of you that will be watching on demand in the future. This webcast is part of our Visionaries series, and we've got an interesting topic to talk about today, which is the future of industrial imaging, particularly leveraging AI and 3D imaging for predictive maintenance and process controls. And I'm very pleased to be able to welcome our two speakers here today. We've got some great ideas for us to discuss and some topics to debate. First of all, we have Noga Barpal, who is the VP of Business Development at Pixie Imaging, and also Linda Eschke, who is the Project Manager Software at Basler. Welcome to you both. Very pleased you can join me here today. What we're going to do is we're going to introduce both speakers. They're going to do small presentations about themselves, their organizations, and the topic at hand, and then we'll get into the discussion. If you want to join the debate, if you want to ask a question, there is a box at the bottom of the screen, so just tap in there and we will get to those questions as we can. We're due to run about an hour, but we may run a bit over, we may run a bit under, depending on how much impact we get from or involvement from you watching live. So, with no further ado, I'm going to go to Noga, who is going to talk us through who she is, what Pixie Imaging is about, and welcome, Noga, and over to you. Thank you.
Thank you so much. Thank you for having me today. It's my pleasure to introduce Pixie Holographic Imaging. So we are recreating the concept of what it means to have digital imaging. And I am sure everyone on this call can understand the importance of imaging in our daily lives, right? It surrounds us in our cell phones, in our cars, when we watch our family, and when we're at work, and keeping our coworkers and ourselves safe. So it's a very paramount part of our lives, and yet it's really stayed the same fundamentally since the beginning of film photography. We've had great leaps in miniaturization of the technology and improved resolution and such, but the actual fundamentals of how photography has been done has stayed the same. And that's about to change with Pixie's holographic imaging technique. So we actually view light differently than traditional cameras. And this unlocks new potential in all spaces of digital imaging. And today we'll focus on what it means for the machine vision market. And so I'd like to first give you kind of an idea of what this technology looks like. So if we take a point of light that's radiating towards a lens, that light information, the wavelength information of the light can present to us information like the color and near IR, and also the depth information of the target. So if we follow this point of light into the camera lens, we take a standard camera lens, the light hits those lens and is then focused onto Pixie's holocoder, which is a proprietary phase mask. It replaces a color filter from standard imaging today. The light is focused onto that holocoder through the lens, and then is diffracted by the holocoder and recorded by the CMOS sensor. So again, a standard CMOS sensor that works today. And then we decode this white light hologram through our proprietary algorithms on an ISP, and are able to then output a color image, an infrared image, and a depth image, all from a single sensor, single snapshot per frame. So all of this is natively fused, and we're able to then give much more information versus standard cameras. And you can understand, I'm sure, if you're coming from this market and you're looking at process control, et cetera, that you have limitations of today's cameras that are really paramount in the world of machine vision, right? You have limitations with low light performance, or issues with ambient light, et cetera. You have obviously no depth perception, so you need additional sensors if you want to do depth and color images. And there's things like optical distortions and limited depth of focus. And I'm sure you can all think of many more limitations that we have in today's cameras. And this is what Pixie is seeking to address. So here we have an example of our technology. We're giving both the depth and the color image natively fused at the output of the sensor. The depth information you're seeing on the human and the dog is taken directly from Pixie's depth information. We have very high accuracy, and we have the ability to work in any range. So this is showing up to about 16 meters. We can go farther than that. We can go closer than that. And in just a second, here you'll see a closer range demo that we show an example of cans that are, to the human eye, seemingly the same height. But to the Pixie sensor, you can see the height difference from the ones annotated in blue and orange. And these are kind of the anomalies of the cans. But again, both the color image and the depth were generated from a single, otherwise standard camera. So in terms of machine vision, this allows us to provide higher performance than today's cameras. Both from a low light performance perspective, we get higher SNR compared to today's cameras, but we also are able to give depth accuracy with depth information with very high depth accuracy. Again, depending on the application, we are probably surpassing today's depth solutions that are offered in this market. And we take the underlying specs of the camera, which enables us to really operate in any condition. So it can be anywhere from microscopy all the way to long range robotic, obstacle avoidance and things like that in the workplace. So we have very high performance and additional functionality while reducing the cost of systems. If you're currently using stereo cameras and other depth solutions, other color cameras, all at once, we're able to reduce the number of sensors and offer you multiple outputs with a single sensor, which again also has a host of system perspective to lower the power consumption, the processing power, and so on. And this ultimately can impact your integration where you have a single sensor, a single output, and we'll talk about that a lot today, of what that means for you to implement this in your systems. So that is a little bit about Pixie, and thank you. We look forward to talking with you in the future and for the discussion going forward.
Thank you, Noga. That was really interesting. Right, Linda, product manager at software at Basler. Maybe you could take the floor, please, and talk us through what Basler's up to and a bit about yourself. Thank you.
Yes, thank you, Mark. So I will also share a presentation that I've brought. Yep, now you should be able to see it. So yeah, as Mark already said, so my name is Linda Reschke and I'm a product manager at Basler for our image analysis tools. And today I would like to share some insights with you how we at Basler see AI boosting industrial process control. Before I start, a few words on my company. So Basler AG is an international leading manufacturer of high quality vision systems. And we're a publicly traded family business based close to Hamburg in the north of Germany. Basler's commitment to innovation, quality, and customer satisfaction positions it as a trusted partner in the world of vision technology. As the computer vision continues to gain significance in the industrial sector, our commitment is to support a diverse range of markets, helping our customers to tackle their unique challenges. In the realm of factory automation, predictive maintenance and process control are crucial, so particularly in areas like battery cell production. In the overview, you can see all process steps from raw material to ready battery, a lot of steps where errors can happen. So by implementing robust process control measures, manufacturers can produce high quality, reliable and safe battery cells efficiently. Let's have a deeper look into the coating step here. So the one at the second step. So one of the first steps in battery cell production is the coating. The coating process is vital because it directly impacts the battery capacity and efficiency and overall performance. So proper coating ensures that electromechanical reactions within the battery are consistent and reliable. By delivering the components for a visual quality assurance system, we are able to make the process robust and reliable, and after all, to reduce the costs. In this case, the image processing during production presents multiple challenges. So very high production speeds and very small defects, which generate large amounts of image data. At the same time, determining the exact type of the defect is important for ensuring the quality of the coating process. So how can we solve this problem actually? The answer is with a combination of hardware and software products that work perfectly together. With a line scan camera, it is possible to realize such a high throughput and image quality for this demanding application, tailored with lens and lighting as well. By doing customized pre-processing on a programmable frame grabber, the necessary focus for further image processing is created. So by determining the region of interest, only the areas with irregularities are localized for inspection, meaning only the image data from the region of interest is processed. This allows the CPU of the IPC to continue to be used for actual system control without any additional CPU load. In the next step, the irregularities within this region of interest can be further analyzed by AI technology. So why do we need actually AI here? Because of the wide variety of defects, which you can see on the right side, classical image processing algorithms are doomed to fail. Furthermore, the system can continuously be improved, increasing the accuracy and adapting to new types of defects. AI provides detailed classification of defects, which helps in diagnosing root causes and implementing corrective actions. With Pylon AI, we provide a convenient toolset to perform image analysis tasks using deep learning technology in combination with industrial vision system. By incorporating advanced deep learning models in vision applications, Pylon AI can solve complex image analysis challenges going beyond what traditional image processing methods can do. Common AI tasks include classification, object detection, and as well as segmentation and optical character recognition. Particularly in industrial and commercial environments, it is crucial that deep learning solutions can be utilized without extensive IT or data science expertise. These solutions need to be easily integratable and scalable to quickly and effectively address a wide range of applications. So simplicity and efficiency are therefore the key to be successful in implementation of deep learning in practice. So the solution we provide to make our customers' life easier is called Pylon AI. You might ask, what is the advantage that you gain with our AI solution? And the answer is efficiency. So our platform offers very high flexibility due to the general Onyx AI model format. PyTorch, TensorFlow, or NVIDIA Tau are supported by our framework as well. You can maximize the performance of your vision solution by benchmarking your AI models across different processors and AI chips to select the best hardware for your performance and budget requirements. And if a specific hardware is selected, you can optimize your AI model for your processing hardware and enhance your application. Last but not least, you can easily create your vision pipeline via drag and drop and deploy them to the target application using our proven Pylon APIs. We at Basler, we promise that AI vision system make your applications faster and more precise. So we can support you there and your company as well on this journey and with our vision expertise. So all you have to do is contact us. And I think we are also going to talk on this in the next few minutes, hopefully, and can discuss on this further. Thank you.
Thank you, Linda. It's a fascinating kind of time to be talking about this topic because it always strikes me as a perfect collision of different systems, different approaches, all kind of with a single aim, I guess, in terms of being able to see faster, better, with more accuracy, et cetera, et cetera. It's really interesting, the difference of approaches around this. I wanted to start with a fairly general question. I mean, if we agree that these are all about improvements in maintenance, process control, et cetera, I mean, what do you think have been the biggest obstacles that these kind of technologies have overcome? And what's next? What are we kind of trying to fix next with these sorts of technologies? I don't know. Linda, what's your take on this? I mean, in terms of the approach that we're taking now in terms of trying to kind of, launch new kind of technologies, what do you think are the fundamental kind of hurdles that we've overcome to date and what's next?
So, I mean, the natural development is that the industry always strives for higher efficiency, improved quality control, and also for cost reductions. So I think vision technology is the important key factor to help here. You could go with like proactive actions as minimizing downtimes or extending the lifespans of assets with like analyzing the visual data to try to determine whether the assets have like end of life or whether there is like a maintenance failure. So if you like have this kind of issues, you can definitely go one step further. Another topic that I would say AI is very strong in having those high precision industries as semiconductor and manufacturing. This is also, I think, where AI is like going like the last mile. Challenging, I think, is the topic of deployment in B2B, because we always, when we talk to customers, they're like, okay, I already have my trained model to solve the problem, but how do I deploy it? How do I optimize it to like the specific hardware? And that's where we try to help our customers here. Because in the end, you have to make it like scalable, right?
Yeah, and I guess there's never a kind of consistency around that. It's almost a unique time every time you come to put this in. And Noga, from your perspective, similar kind of views on the challenges that this is overcoming?
Yeah, I think that not just in this market, in all markets, everything is going towards AI and machine learning. And so as we reach that stage where I think all understanding that the AI models are only as good as the data that they're fed. And so how can we get the best data? It has to be, in scale, it has to be large enough where we have the data and the quality of the data to feed this these neural networks. But you also need to have this in a scalable way, like Linda said, that you're not just overloading the system. Now you have endless power consumption and processing needed for this. So I think that this kind of holistic view is something that has to come both from a hardware perspective and the software. AI can get us so far, but ultimately the foundation of what it's being run on is what's important. And so that's, I think, the big challenge is trying to find technology that doesn't now require you to have 50 different systems in any given place, that you can have some sort of efficiency and reusability and scalability across all of these products, but also gives you the data that you need when you have diverse needs across any given location.
Yeah. And when you're talking to people wanting to implement these systems, is there a common pitfall that they're all falling into in terms of too much expectation about what can be done or the length of time it will take to actually integrate this into something usable in their context? Are there a kind of things that they always get right or always get wrong? Noga, what was your take on that?
So I think as a general answer, there's always a trade-off between cost and performance. And there always has been traditionally. And so there's this issue inherently that, okay, I can get everything I want, but it's going to cost me a lot. Or I'm going to spend many, many hours and years trying to integrate and create a system that works off of that. And so I think that that's one of the challenges today, is to try to find something that you have limited trade-offs.
Yep, that sounds good. And Linda, would you agree?
Definitely. I would just add one point to this. So I think a point where our customers often stumble over is having the right performance in that as well. So as you said, it's always a trade-off. But if you feel that you have to train a model to fulfill a requirement of having like 150 frames per second, then you say, okay, we might do it, but somewhere we have to make a trade-off. And if it's like reducing, for instance, the amount of data that is processed per time, or if it's putting in more and more development effort, so there's also like a trade-off that we have to go for. But other than that, going fully with Noga.
Yeah. Okay. I wanted to ask a little bit about filtering considerations, particularly perhaps when we're talking about 3D imaging equipment, but I guess it's true sometimes for AI as well. What considerations do people need to think about before they start working on a kind of an integration? Linda, do you want to answer that one to start with?
I'm not the typical 3D expert, I would say so.
Yeah. Okay, fine. That's fine. I'll go to you, Noga, if you'd rather answer that first.
Yeah.
I'm just wondering. I always wonder with these things whether there's commonalities of challenge, around the different things. I mean, it's a 3D imaging question, but it can be applicable to AI, I guess, as well. I mean, Noga, maybe you take it first, and we'll go back to Linda. Give her a moment to think about it.
Yeah, I think it's very much universal between 3D, but all imaging devices. You have to understand what is the application. Are you imaging something that's moving or static? What kind of frame rate do you need for this? What kind of resolution is needed? The range. I think 3D imaging specifically is very particular or sensitive to the range as it relates to the resolution that you need. And that's, again, been something that's traditionally been a really big trade-off, is that you don't have one 3D imaging system that fits everything. If you need static versus movement, you might need two different systems. If you have ambient light and another place you have other lighting, you have other calibration issues. So you really need to define what it is that you need to get out of the sensor and what it is imaging, and then pick the technology that fits that the best.
Yep. Linda, anything to add from that from an AI perspective, perhaps, or just from your own experience with working in this technology area?
I mean, it isn't a 3D or AI, so I would just add, I mean, in the end, it also depends what technology you're using to process the image that is coming out of it, and it all comes back to the use case that the customer in the end has, or the problem he wants to solve. So it always is it is somehow always a case-by-case decision, which is the best. I just think that having AI gives us more possibilities to go deeper into applications. So in the presentation that Noga showed, it was this man going back and forth, and it was always detected. And this wasn't, or this is not really possible with classical image processing algorithms. So this is the point where we have to step in with AI. Having those diverse information that all goes back to where is the person information.
And I had a question that's come in actually from Pierre. The FOV, seems very narrow, about 30 degrees. This is in specifically the presentation that you gave, Noga, about the demo with the dog. And the question is, what is the trade-off between the working range and the FOV? Is there a view on that?
Good eye, first of all. But basically, we inherit the specifications according to the lens and the sensor. And so we're agnostic. We can work with any lens and any sensor, but ultimately, and then that will obviously impact the field of view. Ultimately, from a depth perception perspective, the depth accuracy depends on the range and the lens aperture. So if we have a certain lens and we're working with a few meters, you can get centimeter resolution. It really depends on the application, but we have anywhere between sub-millimeter resolution to a few meters resolution, up to 100 meters. So it is quite an accurate solution, and the field of view will adjust accordingly. But again, we have flexibility in terms of if we need very narrow field of view or wider.
Yeah. Okay, that's interesting. And another question that's just come in, I'm not sure who this was particularly aimed at. This is from Martin Millington, asking about macro and high magnification implementations. I guess this could be perhaps one for you again, Noga, but.
So so we can work on microscopy solutions as well. It's very similar answer to what I just said in terms of the lens. Microscopes obviously have some certain considerations as they work obviously separately than what we are used to in regular cameras, but we have situations that we've worked with them and we can offer additional value. I touched very, very high level on what Pixie does and really stress the multi-channel output that we give, the RGB depth IR. But we also have additional features that we can offer, such as all-in-focus imaging or focus stacking for microscopy can be really interesting. So if that's an application that you're interested in, feel free to reach out to us.
Okay, thank you. Linda, if I could, I'd like to ask about all-in-one solutions and how easy they are to integrate with a range of platforms. Are there any particularly that you think are good, or things that people need to think about when they're considering that as a solution?
You mean like going over to Pylon AI, right?
Yeah.
I mean, in general, I would say Onyx is one of the like buzzwords you have to think of, because it's like the general format that represents like machine learning models. And we also integrated Onyx just to be like cross-functional or what's the English word one, like compatible with other other frameworks there. So as like the words I already throw into the bin, like TensorFlow, Keras, PyTorch, all those formats can be supported when you support the one, so Onyx. And that's why we also try to be like flexible with having this general framework-wise implementation.
Okay,
Mark, are you
that's
still
good.
there? Yeah.
I am still there. Can you hear me? Can you hear me?
We
okay.
can hear you, but
okay, I'm really sorry. I don't know what's
working.
gone wrong with my camera. It's it looks like a cable has disconnected or something. So I'm going to have to call some IT help. Apologies for that. But I'm still here, so you can talk. Okay. You just can't see me, which is probably a relief, I'm sure. And obviously, all of these emerging tools aim to simplify a range of industry challenges, from sensor and hardware selection to AI-powered analysis. How are they doing that today? Is it about speed? Is it about power consumption? What would you say are the big emerging tools that are really making a difference now? Linda,
sorry.
do you want to go first? Yeah. Sorry.
Okay, sorry. Yeah. So basically, one of the topics that Nogo already mentioned is like multi-sensor fusion, which I think is a really emerging topic. Another one is for me definitely like getting into topics like automated annotations, but because like having the basis or having the data right is one of the key factors that make AI successful in the end. And this is like only achieved if you have a lot of good data going into your model. And that's why I would say like automated annotation plays also a role, because we can help people doing the annotation right and like getting faster into that. So those would be topics for me that getting more and more important as well. Another topic that I think is quite important is also looking into helping in medical healthcare, so like supporting diagnosis of cancer and so on. So this is also for me like a topic that is like going straight forward. But yeah, diverse range of topics that we can put on the table here, I would say.
Okay, that's interesting. And Noga, similar kind of perspective from your side?
Yeah, I definitely think Linda spoke to the big parts. I would say one thing we're seeing consistently is the rise in 3D imaging as an answer to a lot of issues that are being opened up in the field. So I think we saw, like, if for those of you who attended the Vision conference this year, there was a huge range of 3D imaging products. Obviously, Pixie is one of them, but there's a lot of tools that are out there to, if it's for medical or if it's for robotic navigation or what have you. It's really, I think, an up and coming trend.
Okay, thank you. Apologies, you still can't see me. We're trying to fix things at this end, but it's the trouble with doing this live. You see, you always end up with these sort of issues from time to time. Power consumption is something that obviously everyone is concerned about, both in terms of big scale issues as well as small devices and things. How is this technology eating up power, and what improvements do we see coming down the road around this? Are they very power consumptive, and are there some mitigation steps that you're working on or people can work with?
Definitely. Definitely. I mean, it's obvious that cameras and also the technology and software behind is taking up power consumption. I mean, if the alternative would that a human being would see this or do like a visual inspection, but I think there are like different tools to optimize the power consumption itself. You could like directly optimize your model or make your hardware more energy efficient. So this is also something you can do via benchmarking and seeing like where is my model running efficiently on the hardware or not. But of course, you also have like the indirect point of power consumption saving. If you see that, for instance, for predictive maintenance, you could train an AI model to see whether errors are occurring in the future. And instead of reproducing an object once more because it's going wrong, you just save the time and the power before because you see the error before it occurs, you see? So there's like this direct, I would say, power saving, and this indirect by just optimizing the whole process. And this is, I would say, a big topic that you can see there.
And Noga, same sort of. What about from your perspective? Do you find 3G imaging is quite power consumptive, and are customers, clients, partners worried about that? And what can be done to improve it?
Yeah, we see. Oh, and there we go. You're back. As Linda touched upon, basically from the hardware perspective, that's a big part of the current power consumption. I think what we see in the field is that people are needing a lot of different sensors and then the sensor fusion to address their need. And obviously, the more sensors you have, the higher power consumption. So for kind of an all-in-one imaging device like Pixie, we can reduce the power consumption just by reducing the number of sensors. And then there's the added value of having, a natively fused, fully synchronized system for the AI model to run on. So I'm not sure tangibly if that adds to or kind of reduces the power consumption as well, but it obviously is easier from an integration perspective and data integrity that everything is coming from a single source.
Okay. And I wanted to ask actually, of course, about data. I mean, it's obviously critical to everything, really. Is it easy to decode and manage imaging data without any programming expertise? How, sophisticated and how kind of literate do you need to be able to work on these things? Noga, I'll ask you that one first, if I may. And we'll get to Linda next.
So I can only speak on the Pixie technology. I'm less versed on others, but from Pixie's side, what we provide the software that has the decoding of the holograms. And so what we're outputting is an RGB image, a near IR image, and a depth map. And so from the integration perspective, usually you have a system integrator that is offered, either it's Basler or another provider that's doing something customized for you, but eventually the data that we output is quite standardized from that perspective, and you're not required to have any AI on top of our data. For example, you're getting the outputs, and then you can take it from there.
Okay. Linda, what's your take on this? Do you have to be an expert, or is it easy to get into?
Yeah, I mean, in the end, if you want to do everything yourself, you have to definitely be the expert, but there's also from our perspective the topic where we take you by the hand and do the things for you. So you can definitely count on Basler, for instance, to go with you through the whole MLOps cycle. So from data annotation until the final deployment, if you're not willing to do it, or if you cannot do it because you just don't have the resources. So we see there a lot of teams contacting us that have vision expertise, but they just say, okay, I need my energy for other projects. And that's where we want to step in and want to help as well. So yeah, in the end, you can do it without any programming expertise. You just have to then pay a little money for it, I would say.
And just from a practical perspective for both of you, what's the typical kind of experience in terms of working with customers, clients, etc.? Are they coming in with a ready-made team with a very fixed idea of what they want to do, or is it much more iterative than that? Linda, I'll start with you first, if I may.
It's definitely both. So we have big OEMs or system integrators that say, I want this camera, I want this lighting, I want this lens, and I already have my software in place and I want to do it. So there's only the part where we can sell components. But also there's the other part of the customers that are coming in with, I want to solve this problem because I need some more information on my product or anything, or I want to optimize this process. And then you have the full range from advising on the right hardware and advising on the right software to solve the problem. So I would say it's both, and it's not bad or good. It's just like the way projects or customers are.
Okay, and same sort of perspective, would you say?
Yeah, obviously our business is very different than Basler. We're providing a portion of a larger system. And so we typically have customers who are coming knowing that they have a pain point with the current options on the market, or they want to reduce costs or form factor or whatnot, with the very specific considerations that Linda mentioned as well with lighting. And if, they need a certain frame rate, they know what their application is. They just don't necessarily have a system on the market today that addresses it exactly how they want it. But in terms of working with them, we obviously usually go with a system integrator, at which point the system integrator can usually advise what's kind of the overall best system for them.
Okay. Noga, we've had another question in specifically for you, which is from Eran, and he is asking, what is the update rate of the depth information?
So you're getting the depth information with every frame. So every frame you're getting both the RGB and the depth. In terms of resolution, we don't provide the full resolution of the sensor per depth. It's usually not necessary. So it's usually about a 9:1 ratio. So if you have a 9 megapixel camera, you're getting 9 megapixels of color, and you're getting 1 megapixel of depth, but it's per frame.
Okay, interesting. Okay, hope that answers the question, Aaron. Another question just about what this is doing in terms of the real world applications. Are there particular areas where you are seeing a lot of interest relative to other markets? I'm obviously thinking about the obvious sectors that we all understand, medical, life sciences versus agriculture versus defense, et cetera, or industrial kind of context. Where is this being utilized most widely, and in some cases, what would you say is most interesting about that view? Noga, I'll start with you again, if I may.
Just to make sure I understand the question, you're saying in general, not just in this market?
Yeah, where are you seeing a lot of interesting activity? Where are you seeing a lot of interest from clients, and why is that interesting particularly?
Yeah, so we see a lot of interest on the low light capabilities of ours, and that actually surprisingly spans across every industry that uses cameras today. So there's been a lot of advancements with AI being able to improve the lighting of an image, but like we talked about in the beginning of the call, that can only take you so far if the foundation of the sensor gives you a dark image. So we're seeing a lot of interest in the low light performance. And I think that from an industrial perspective, it's been very interesting in terms of our flexibility with the lighting conditions that are typically difficult to maintain a single type of lighting condition throughout your factory or where have you. So that's something that's been across the board, but I would say kind of the biggest camera markets of mobile, consumer electronics, and automotive been very, very interesting. And then from like RGB depth, we see a lot of interest in the industrial space for sure. I would say also automotive and mobile are interesting from that perspective. And then I mentioned, like, we have a lot of other features that we can offer that can be very industry specific. So one example is being able to place cameras under display. And so you can imagine that, Martin, you know, I don't think that that's super relevant for industrial, whereas in mobile phones, for example, that's an issue that they've wanted to address for years now. So it really depends on who we're talking to. But generally speaking, the cool thing about this technology is that it can actually really be a replacement to all existing cameras and offer different benefits depending on the application.
Yep. Okay. And Linda, from Buzz's perspective, you're seeing a kind of sweep of interest across industries or any particular areas of focus?
I would say it's very diverse. So we were very surprised that a lot of food and beverage interest is in the topic. But in the end, this is also kind of a process control or factory automation topic. So it's just like a subtopic in there. Finding anomalies in food is more complex than in just like a specific metal part, for instance, which is like always the same. But if you have like maybe an ice cream, you have like different shades of how it's looking like. And this is like where we found it's surprising that AI specifically has this trend in food and beverage, also in like pharmaceuticals, because like they also have most of the times liquids and complex tasks to solve there. And which I also see is very important topic, or where we gain a lot of interest, is in optical character recognition, especially. So reading text on boxes, on packages, on letters. So this is, I would say, a topic where we definitely have a lot of potential across everything. So logistics is in there, factory automation is just in there for like tracking a part through the whole process. So this I would say are the most important ones at the moment. But for instance, object detection is always also a part in traffic surveillance. For instance, you always see those videos with like, is it a truck? Is it a car? So basically, also supporting stuff like autonomous driving, for instance. So yeah. I would say it's very diverse and also very interesting topic.
Obviously, this is still relatively new technology. I guess, you know, relative is a very subjective word. Low light is something that we have heard about forever, really, in this sort of market. Is there a point at which the technology is so ubiquitous and so well integrated into every kind of context that low light just doesn't become an issue anymore? Do we always feel we'll be fixing something around those sorts of issues, or is the technology that we're now beginning to see, you know, kind of in use more widely, going to get to a point where those sorts of issues perhaps disappear because the technology will be so, kind of obvious and integrated already? What's your take? How close to just a 360 solution are we around being able to see accurately in a lot of different contexts? Linda, I'll go back to you, if I may, on that one.
I'm not sure if I got the question right. So you ask whether low light is basically already solved, or
are we getting to a point where the technology will solve this issue, or at what point do cameras and the software that supports those cameras and the imaging equipment work so well that there's almost not a debate to be had about what it's seeing?
I wouldn't say it's solved. So there's always, we always have the hardware, so to say, restriction, or the environment restriction. So we can improve low light scenarios with AI by maybe adding some perspective from another sensor, by adding or like filtering out those variations that the human eye might not be able to see. But we will always have restrictions. So whether you're like in a process where you don't have any like visual light at all, you have to go for the other data. I wouldn't say it's solved yet, but it's like a very interesting topic to go into further, and we're always happy to have a look into those different challenges.
Okay. No, good. Well, what's your take on this? Are we there? Are we close to getting to solving this today, or is there always going to be another challenge once we fix the next challenge on the roadmap?
Yeah, I think as Linda said, we were making a lot of advancements, and it's incredible how fast AI is adapting to our world, and will probably surpass human capacity quite soon. But at the end of the day, it relies on the underlying data from the hardware. And so even if AI gets to a point where it can give a pretty good estimation of everything using the current hardware, I think the next step will just be cost reduction. So if right now you're needing additional sensors to address it, like Linda said, you need the visible light, and then you eventually need IR for something else. Is there a way that we can minimize the sensors, reduce the size of the sensors? So that's generally the trend of technology. So I think that will be the next step, but I'm not sure that we'll even get there yet, because ultimately there are still limitations to what AI can do.
Okay. So, I mean, obviously the topic, we've talked a lot about different contexts, we've veered off into sort of life sciences, etc. The future of industrial imaging, you've talked a little bit about cost as being the next big goal to be overcome. This is obviously costly to develop, costly sometimes to implement or integrate. What do you think the number one sort of big future trend would be, as a sort of a way of kind of concluding the session? What's next, the next big thing on the horizon in terms of what we're going to be seeing from this kind of technology going forward? Linda, I'll come to you first, if I may, on that one.
Wow, this is like something very futurist, I would say. What is coming next? I wish I would know, to be honest.
We all do. You're not alone.
Yeah. If so, we would have already solved it, I guess. So, to be honest, the whole industry is so wide. We get surprised every day by requests from our customers. Can you solve this? Can you do this? And this is like, I think, the very interesting thing. Just general, like, where is it going? I go with Nogard. Like, cost reduction is like one of the most parties where we get into the topic with the customers, because they might have existing solutions. They might have also solutions that are not working yet. But in the end, everything has to like still be competitive, and that's the way I would say where it goes.
Okay, so we've got another vote there for cost and economic context. Noga, anything to add or contradict to that?
No, I think Linda said it better than I can say. Maybe one part to add would be just the kind of adding robotics and drones into the mixture to reduce human failure or what have you. And so that adds a complexity of how do we enable robots and drones to be in those environments in a safe manner and in an accurate manner. So you obviously have tons of robotics today, but is this going to be, autonomous moving robots and things, and drones that are actually really doing the work inside, outside, amongst humans, by themselves, etc. So I would say that automizing from that perspective might be a much bigger deal than it is today.
Yeah. And I think that's a very good point, isn't it? I mean, at the end of the day, this is a technology, but it fits in around a range of different contexts, with a lot of adjacent technologies that need to support it. And you know, what we develop in one context will need to be applied somewhere else. And in time, the solution becomes more rounded, more effective, scaled, etc. Thank you to you both. I've really enjoyed the chat today. Thank you to the people that have sent in those questions. This webcast will continue on demand, so you can find it at imveurope.com for up to a year after today. So please pass on the information, you know, if you found this useful, to colleagues, because you know, both speakers, I think, have done an excellent job of presenting their perspectives on what's quite a complex but broad kind of area, and there's a lot of interesting development going on. I think both speakers would appreciate any reach out, so you've got their contact details through the webcast, and the, you know, the contact details that were shared through your registration. So thank you to you both today. Thank you to everybody that's been watching, and we hope to see you again at another of our webcast series. Thank you.
Thank you.